Let's sketch out the Lewis structure for N2, which is nitrogen gas. To accurately depict the Lewis structure of N2, follow these steps. Start with a rough sketch. Illustrate the chemical bonds between the nitrogen atoms. Identify and indicate any lone pairs on the atoms. Verify that the octet of each nitrogen atom is complete. Conclude by calculating formal charges, aiming for a stable Lewis structure with the least possible formal charges. Before drawing the rough diagram, we'll first calculate the total number of valence electrons and then identify the central atom. The total valence electrons in N2 are determined by summing the valence electrons of each atom. Nitrogen, a member of group 15, possesses 5 valence electrons. With 2 nitrogen atoms in N2, the total valence electrons calculation is 5 for 1 nitrogen multiplied by 2, resulting in a total of 10 valence electrons for N2. The central atom for N2 can be either of the 2 nitrogen atoms. Opting for the right nitrogen as the central atom, the preliminary sketch of N2 involves positioning the 2 nitrogen atoms in a straight line. 2 electrons represent a single chemical bond. Therefore, we will place 2 electrons between the 2 nitrogen atoms to indicate 1 chemical bond between them. In this way, out of the total 10 valence electrons, 2 are used, leaving us with only 8 electrons. Lone pairs consist of electron pairs not utilized in chemical bonding. Remember, each pair comprises 2 electrons. With 8 electrons remaining, mark 4 electron pairs on the structure as lone pairs. It's important to note that nitrogen is a period 2 element and cannot hold more than 8 electrons in its valence shell. Also, remember to always start marking lone pairs on outside atoms first and then on the central atom. In N2, the nitrogen atom on the left will receive 3 lone pairs, while the central nitrogen atom on the right will receive 1 lone pair, as we only have 4 lone pairs available for marking on the structure. The octet is complete for the left nitrogen atom, but not for the central nitrogen atom. So let's now focus on completing the octet for the central nitrogen atom on the right. First, recall that nitrogen is a period 2 element and cannot hold more than 8 electrons in its valence shell. The right nitrogen already possesses 4 valence electrons and requires 4 more to complete its octet. Therefore, we will convert 2 lone pairs from the left nitrogen atom and transfer it to the right nitrogen atom to form a chemical bond. Now, it is evident that each nitrogen atom forms an octet. Thus, the octet rule is satisfied, and now we will calculate the formal charge and check the stability of the structure. This is the formula we can use to calculate formal charges for the N2 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Input the data and place the values to derive the formal charges for each individual atom. For each nitrogen atom, valence electrons are 5, non-bonding electrons are 2, and bonding electrons are 6. So the formal charge will be equal to 5 minus 2 minus half times 6, which equals to 0. The formal charges of both nitrogen atoms are 0. Therefore, this structure is the preferable stable Lewis structure of N2. To represent a pair of bonding valence electrons, we can simply draw one horizontal line. Since there are 3 pairs of electrons between 2 nitrogen atoms, draw 3 horizontal lines between them, signifying a triple bond between the 2 nitrogen atoms in the N2 Lewis structure. So, that's the Lewis structure for N2. If this breakdown was helpful, press the like button, share the video, and subscribe for more chemistry knowledge.